Hi, I'm Nate Adams, CEO of HVAC 2.0, and it's really important to understand what the 2.0 process is capable of. Because we built this process to be able to fix any house. So you need to be able to confidently walk into any client house with any level of complexity of problem and know that you can fix their problems. The vast majority of houses are not going to need the deep fixes, like what I'm going to talk about in this video. But the fact that it's there gives you the confidence that you need to walk into it. So this is a big piece of what makes HVAC 2.0 so very special. So we're going to go through the HVAC 2.0 process as a case study. So we're going to look at an advanced project. Now, I adapted this presentation from a webinar that I did with RetroTech, which is one of the blower door manufacturers. And I did this live with the client. And I will link that video below, and I'll actually have this video roll into that video when it's done. But what I wanted to do this time around is buzz through it pretty quickly and hit mainly the high points of how the 2.0 process looks when you apply it to a tricky project, because this was not an easy one. I've done harder, but this was a pretty tough one. So, and to start, the skydiving engineer, this is Peter, my client. He's awesome. He's a lot of fun. This is Peter jumping off of a perfectly good cliff in a wingsuit. So he's an interesting fellow. He was awesome to work with. All right, so let's take a quick look at the HVAC 2.0 process. This is a simplified subway map, and it's based on two questions. Are there comfort problems to solve? And then, is HVAC likely to solve the problem? So here is how it typically works out. So if you have 100 leads come in, 70 of them or so are going to go free quote. 30% of them or so are going to go to the comfort consult. Of those, almost all of them are going to do a tailored replacement. So it's basically going to be HVAC only. Maybe you'll touch a few other things, but it's going to look pretty similar to what you do now, only it will be a larger project, preferably with better margins and more interesting and better results. But a few of them, 3% or so, so if you start with 100 people, maybe 3 of them are going to go through what we call the comprehensive planning process. And the way to look at this is free quotes are like a clinic. So if you have 100 people and 70 of them have boo-boos and they need aspirin or a Band-Aid or whatever it might be, but they can get fixed up pretty easily. So that's what that is for. You're just going to do a basic change out, like for like. Then you have people that have some real injury, some real problem. And so they go to the emergency room. At the emergency room, they get split into either going to the OR, so say they broke a leg, they do an x-ray, and they set the bone, and they send them home. So not that big of a deal, basically outpatients. And then some people will be in really bad shape, so they need to go to the intensive care unit. That is the CPP, or the comprehensive planning process. Without having this, 2.0 breaks. This is what we figured out first, and then we had to figure out how to back into the rest to make it compatible with the HVAC business model. But this is where we began. This is where my partner and I cut our teeth. So that's what this is, and we're going to walk through one of these. This is also what makes HVAC 2.0 special. So it is 2.0 because it deals with the whole house. HVAC 1.0, business as usual, deals with the box almost exclusively. But if you want to actually solve problems, the box is half the equation at best. Oftentimes it's less. You have a leaky house, the box almost doesn't matter because the house is so messed up. So 2.0 lets you look at the entire house as a complete system of systems and then peel apart what needs to happen to make that house better. Huge chunk of them, again, are just going to need HVAC. But some of them are going to need the more advanced projects. And this is something, again, you can largely sell away from this. And in time, there will likely become a network of people who specialize in just doing this. But for now, you need to have an idea of what it looks like. So here's what we're going to go over. We're going to go through that process. So Peter did a comfort consult. This was me doing my own independent consulting. I am not an HVAC contractor. And then we dove into the comprehensive planning process, and then we did a project based on the planning that we did in the comprehensive planning process. And for the project, we're going to talk about finalizing scope and bids, prepping for insulation, doing the HVAC, doing insulation and air sealing, and then optimizing once we had everything together. Sounds like a lot, and it kind of is, but it's very doable. This isn't that big of a stretch from what you do now. And this shirt I've always loved. Actually, we should probably get these made. We do precision guesswork based on unreliable data provided by those of questionable knowledge. When it comes to fixing houses, you can never know as much as you would like to know. So you always want to hit a little bit harder than you think you might need to so that you're much more likely to solve the problem. The good news is we can use feedback loops and we can make this better, but there's still limits. So 2.0 is built to understand where these limits are and work with them rather than against them. Very critical. All right, comfort consult. This Venn diagram is going to be very familiar to you. If it isn't already, it's going to be very familiar. These are the three things that need to happen in a comfort consult. You need to understand what are the client goals, what does their house need, and what is their budget, which isn't what will it cost to fix, it is what is it worth to fix. Very different, very important distinction. If you pull all these together, you can see if they cross and if you have a viable project, or a better way to look at it probably is there a sweet spot in the middle where you can make all of these play together and actually fix things. So here's what the comfort consult looks like. There's an extensive interview. It's about an hour's worth of questions. You do leak diagnostics, that is a blower door, and you do some simple zonal, which is checking how leaky each room is, so you can understand if there's a really problematic room or not. That's good for understanding what next steps look like. Then you're going to discuss your client goals. You'll discuss the problems that you saw as you went through the testing, and then you're going to begin to develop a rough budget. So at this stage, it's not a really hard budget, but it needs to be something. And then when you're done, you send them an email recap, which actually is a report, and pretty nice looking report. I'll do another video on one of those. All right, so here is what Peter told us. And by the way, I should mention, I did this a long time ago. This was a 2015 comfort consult, and this project didn't execute until the end of 2019. This is going to happen on CPPs. So you're going to think that the project is dead, and it's really either people are waiting for the pain levels to come up, they're waiting for the equipment to stop, or they're finding the money. So the closing ratio for me on CPPs is now upwards of 90%. So basically, if somebody does a CPP, they're doing a project. And we have it set up so you can make money. All right, so here's what we found out. Goals. The second floor of the house is very uncomfortable, which makes sense because he had a furnace and air conditioner on the second floor. The furnace died years ago, turned out to have a bunch of bird nest in it, so that's what did it. And then the air conditioner failed a little bit later, which is what started the project. It's a split level, and there was a big cold waterfall that came down the stairs, and that's where they sat to watch TV, so they hated that. And then he plays games with the propane pricing, like he's got plenty of cash, so he will buy a year's worth of propane 6 months or a year in advance. But he was just tired of doing that. He's like, I just want my house to work. I don't want to have to think about it. So those were the things that he wanted to fix. The house was quite leaky, so it was a 1,600 square foot house with a 3,300 blower door, which is pretty bad. And then the budget, he is one of the very, very few people who just would not, for the life of me, give me a budget. He just didn't want to do it. So, and that's going to happen sometimes. The good news is with the comfort consults as an HVAC contractor, that can be all right. You will, there's a line for it, which is, all right, so, one of my jobs is to help understand what the budget might be to fix this. So if you don't want me to finish that job, that's fine, but that is something that is part of this service. Are you okay if we move on without doing that? So you are going to offer or decline them at that point. All right. This is another chart that should become very familiar over time. So this is leakage to square footage ratio. So this is how many cubic feet per minute, 50 pascals, which is what a blower door measures, to square feet is a house. 1 to 1 is generally kind of a sweet spot, somewhere between this 0.75 and 1 to 1. If you get a house in that ballpark, typically you can fix it with HVAC alone. Once you start getting much beyond that number, the house is leaky. So it's like a leaky boat. There's constantly water coming into it. You don't need to fix the engine on that house. You need to fix the leaks first. So that's why you need to test where it is. This also has a large effect on load calculations, which we'll look at in a minute. But Peter's house, 3,300 CFM 50 to 1,600 square feet, which is right about a 2 to 1. That is a D grade house. And considering that this isn't that old, this house is from the 70s, that's pretty bad. So, and that house is uncontrollable with HVAC alone. Plus, he had the 2 systems, which is dumb. 1,600 square foot house should not have 2 systems. Very uncommon in Cleveland and generally just not a good idea. Here's what the house looks like, 1,600 square foot split. And at the comfort console, you run a blower door, and if there's any temperature difference between inside and out, you can use a FLIR or other infrared camera. I use a FLIR 1. They're $300 or $400. They are more than good enough for this task. And so here's a drop ceiling in the bathroom around the shower, and you can see that there's cold coming in here. So this is very intuitive. If it's blue or cool in color, it's cold. You can see the vent here in the ceiling is really bad. So the boot there is leaking quite a bit. And then the bath fan, the flapper in there is not closing. The damper is not closing well. So there's a lot of messy stuff going on in this bathroom. Here's a whole house fan. We are not fans of these, no pun intended, because they leak like sieves. And with dew points going up over the past 50 years, they don't work like they once did. You'll oftentimes just suck a bunch of humidity into the house, and you're more likely to cause mold than anything. So we generally strongly recommend pulling these out. Here's an old recessed light from the 70s, and you can see that's pretty leaky. Here is the rim joist in the basement. This is a very common leakage area. So if you have crawl space, it's the same deal. Crawl spaces in basements look like this. So there's air leakage coming from right up here, which corresponds to right over here. Here's the equipment that he had. He had a propane water heater that I don't even know why it was still running. That sucker was 20 some years old. And a decent 2-stage Trane propane furnace. But propane is now generally about twice the cost of electricity to heat a house with, as long as you stay largely out of resistance. And thankfully, he had a 200 amp panel, which for an electrification, which is what this project was, he doesn't have access to natural gas. And for what it's worth, natural gas and heat pumps in a lot of parts of the country are almost equal on operating costs. They'll be within a couple $100s a year of each other. And with renewable electricity getting cheaper, it's very likely that within the next decade, heating with electricity is going to be the cheapest option in almost all of the country. All right, so that was the comfort consult. We worked through getting an idea of what's going on in the house, what his goals are, what the house needs, and the budget, which I didn't get here. So now we're going to dive into the comprehensive planning process, or the CPP. So here's what that looks like. This is a more detailed inspection. So the comfort consult is 75% about the homeowner, 25% about the house. The CPP reverses those. So this is almost entirely about the house. In fact, I really prefer to do these when the homeowner is not there so that I'm not chatting with them and I can focus on looking for things. So the detailed inspection, you're looking for the root causes of air leaks that you found at the comfort consult. And then you're going to measure and photograph the house so you can do load calculations, duct design, and then you have the measurements you need. So if there are insulation upgrades that you are recommending, which if you're doing a CPP there will be, you'll be able to get the measurements for those so that you can turn those into costs. And these are all things that we will teach you how to do. The CPP, again, you're not going to do this very often. So this is one of those things that you need to trust. We will be there for you. But this is not something that we teach basically until you actually get there. But I wanted to do this video so you see that, yeah, there's a process to it, and we know how to do it, and it's repeatable. All right, then you create a rough work scope. So once you do all this, what I do is I start a spreadsheet, and I basically puke out my work scope. So like this one, we were combining 2 HVAC systems into one, and the insulation's a train wreck in the attic. So we need to remove insulation, air seal, and put it back. And so you're making a big list of all the stuff that needs to do. You're not worried about prioritizing or pricing. You're just puking out a list. From those, then you turn them into packages where things kind of work together. One will be based on their budget. Another will be based on what you think needs to happen to have high likelihood of fixing problems. And again, this is where you will be working together with somebody else in 2.0 to help you out with that. And then you're going to do your load calcs. And then you go back and you present the findings to the consumer. So here's a couple of things that you note in split levels. The bump outs are super common, and they are super leaky. So pretty often if you ask a client, do you note the edge of the room being cold because they're actually stepping out onto the outdoors? They will say yes. So this is something you want to look for in split levels. So every house type has its few things that you need to be looking for when you're doing it. This is what he wanted to get rid of. This is a propane tank. Look, there is another bump out here, and you can see the 2 outdoor units in the back. And then he's got the big chimney running up there. Another thing to look for on splits is in between the sides of the house. So right in this line here, this is typically a big leakage point, and if this isn't, then the other side is. There's usually a big chase that has the electric lines, the power lines, the plumbing lines, all of those are running through there, and it's usually really leaky. On one house back in my insulation contracting days, just by sealing that hole, we knocked half the leakage out of the house. So it's something you want to be aware of. He also had a bunch of recessed lights. These are cheap 4-inch ones. So here is that light in the attic with the light on, and then I turn the light off. Can you see there's light coming through there? So that's an air leak. So I take pictures of those so that I can show them to them, and we figure out a way to address them. Top plates are another super common thing. So here's the ceiling of one room, here's the ceiling of another room, and this is the wall in between them. Note the dirty fiberglass here. Whenever you see dirty fiberglass, that almost always means air leakage. So it is filtering the dirt out of the air that is flowing through it. That's almost always what's happening, and top plates are a very common leakage point. The ductwork was a train wreck, so you can see that the flex insulation was falling off of the flex duct. This duct system, there was nothing to save. It needed to go. I do simple drawings, so I've tried a bunch of different methods, and I keep coming back to graph paper. So, and again, note, this was done at the end of 15, and we didn't actually do the project until 4 years later. These projects don't die. They just come back. So, pretty simple drawings. And then we began to create targets. So the house tested in at a 3300 blower door. Target 1, we want to make kind of a layup, so it's relatively easy to hit. We have high confidence we're going to hit it. And then a tighter target where if things go really well, we can actually get there. And then we do the load calcs, so what size HVAC is needed. And this, by the way, is done during the comfort consult as well. These are more detailed load calculations where you're going to use a different tool. A RightSoft, National Renewable Energy Labs, NREL has a product called BOPT, which is free, and it's really quite good at the level of detail you need for this. But you're going to be doing more advanced load calcs where at the comfort consult, if the load calc takes you more than 10 or 15 minutes, it takes too long. That's rough, quick, and dirty. So what size HVAC is needed? This depends mainly on air leakage and insulation levels. The exception would be if you're down south, windows do matter more. Windows affect cooling. They don't really change heating that much. And then obviously it's size for the hottest and the coldest day of the year. The key thing though is if you're talking 1% design temps, you're talking the hottest 88 degrees of the year and the lowest 88 hours of the year and the lowest 88 hours of the year. 98% of the year is in between those. So you really want a size for that if you want comfort. And what we find is most furnaces are 2 to 4 times larger than what the house needs. And that will be scary at first, but once you run some comfort consults and you actually true some energy loads or the load calcs to energy use and blower door, you're going to be like, oh yeah, I don't need nearly as much equipment as I thought that I did. All right, so here's how the loads came out. So test in the house as it stands is right about a 3-ton house, 36,000 BTUs. Target 1 at 2,200, and this moved we moved some R values a little bit, but basically when you get to about an R20 in the attic, going above that is a diminishing returns curve. So it depends on a bunch of factors, where you live, install quality, a bunch of things. But by reducing the blower door by about a third and going from like an R19 to an R38 in the attic, we step down a half a ton. If we get the house tighter still, and this is basically the same R values between these two, we lose another 4,000 BTUs. So this house in Cleveland, Ohio is basically a 2-ton house when it's 5 degrees out. Now the current HVAC, and actually this is only one of the 2 furnaces that it has. It had 2 70,000 BTU furnaces, but just to match one, which is all that was working when I was there, he needs to have almost triple the blower door to get there. So just playing with blower door air leakage, he needs to have a very, very leaky house. And for the record, I have seen houses this leaky. They do exist, but that is unreasonable. Okay, so the next piece is now about thought process, and I will be doing another video about this because this curve is called the sigmoid curve or the S curve. This is critical to the thinking throughout HVAC 2.0. So let's take a look at what this is. So we think in odds of success. So you are never going to guarantee anything again moving forward. There are no guarantees, okay? There are odds. A doctor, 10% odds that you're going to die during this operation or whatever it might be, or 50-50 odds that this works, whatever it might be. Doctors don't give guarantees. You are now a house doctor. Don't give guarantees anymore. So what we want to do is at least get to 80% likelihood of success, so odds of results. And down here is work that you do or money that you spend because they are distinctly related. The curve looks like this. So the first few things you do don't move things very much. And when you hear people talk about low-hanging fruit, this is usually what they're aiming for. They're aiming for the least amount of work where you can get a noticeable difference. The problem is that's always the path to hell in our experience. You have to go further. So very low odds of success when you're down here. So that's a failure. The sweet spot is the second inflection point up here, where it starts to flatten out after being nearly vertical. This is the best use of resources. This is theoretical. This is going to vary with every client and every house and every budget. But it's important to have this in your mind. You're trying to figure out how can we get here? And that is how we design these projects. And it sounds scary right now, but being a service technician terrifies me. There's so much stuff that you have to know, pull up to any house and be able to figure out basically any system and get it fixed, turned around and moving again. That is way harder than what any of this stuff is. So here's what that looks like in mapping out the blower door. So 2200, It's pretty likely. So, we're in the 80% ballpark, but it might not make the house more comfortable. We may not stop the cold water fall. There's a bunch of things that might not work right. The sweet spot is somewhere in the 1500 ballpark for blower door, and this requires a pretty deep retrofit on the house. Not insane, but pretty deep. And so we break it into 3 packages most of the time. It can be 2, it can be 4. It's going to depend on the client. Package 1 is the budget. And because Peter was driving me nuts and not giving me a budget, I gave him something that was kind of cheap, but also wasn't super likely to work. And then packages 2 and 3 were deeper packages that had more stuff going on. So these are much more likely to actually get you there. So now let's look at the project. So what we needed to do is finalize scopes and then take those to bid. So you're going to handle the HVAC side, so at least you don't have to do that like I have to find an HVAC contractor for it. So we get the bids, so we see exactly where we are. And as it turned out, I finally got a budget out of him. He had 30 grand to spend. And what he wanted to do was 36. We got lucky, and both bids came in 3 grand under budget. So he actually got the entire project for 30,000. And I think one of the contractors was kicking himself for it. But I gave him the scope, and we walked through. So that was not me. Insulation prep. We needed to do that, so get all of the insulation out, do the HVAC, then we needed to put insulation back and air seal everything, and then optimize the HVAC system. So this is where Peter jumped. So what we needed to do, we had to remove the HVAC in the attic, and all the ductwork and all of the insulation up there. So step 1 was get everything out of the attic. Step 2 was air seal the upper attic before we could put ductwork in again. Then we installed new ductwork. Then we installed new HVAC in the basements. And this ductwork also included a duct that went from the basement out into the garage, up, back into a closet on the second floor, and then up into the attic to serve the second floor. So pretty crazy way to do it, but it worked. Then install new HVAC, and then air seal and insulate the rest of the house. All right, so I'm going to share a few pictures of the HVAC and insulation removal. So there was a filter in the HVAC system that nobody even knew was there that was basically clogged. And then this bird's nest was in the furnace flue for the second floor furnace. So this is why it stopped working. But it just didn't bother him enough to fix it because he likes to sleep cool. So it only mattered when the air conditioner upstairs died. Look at how dirty this fiberglass is on the top plate. So this is a very leaky piece of the house. And then here we are doing some air sealing. So Gary Smith of Affordable Foam, he was cutting these baffles and putting them in there so that they could foam up against them. And then there are ventilation baffles running up because this is still a vented attic. But now the top plates here on the outside wall are sealed. Here's what an interior top plate sealing job looks like. You can see this is closed cell foam that goes across. And this is what happened when we had all the insulation out. So we did this in a cold period of the year because clients sometimes will wait too long before they pull the trigger on this. So it was cold, and you can see we got some pretty bad icicles happening there because there's no insulation in the attic at all. In fact, here's what that looks like. So this is an infrared. You can see the heat coming through the ceiling. And here's what the attic looked like. There's no insulation there anymore. So then we got new HVAC installed. We did a 3-ton, 5-stage unit. And like what, Nate, you said it was a 2-ton. Well, the output of this unit is around 2-ton when you get down to the cold temperatures, and it steps down to 25% of full capacity. So I gave him a choice between a 2 and a 3, explained pros and cons, and he did a 3. One thing I don't like about this system, it was so short, there wasn't a good opportunity to get a bad in here with the filter sideways, so the filter's up against the cabinet. It has a little higher pressure than I would have liked, which you'll see. Here's the ductwork going up to the attic. So this is going up through the attic and the garage, it pops through into the closets in the second floor and then up into the attic from there to serve the second floor. So it's supply and return coming out of the basement. And here they are in the basement. Here's the unit. And unfortunately, we had to go around this I-beam. And important note, I offered a duct design here, and he did not take it. So the second floor probably could have stood more ductwork than what it got. But, you know, if you don't specify it, you get whatever the contractor wants to do. So it worked okay, but it would have been better if this ductwork was a bit bigger. Here's the outdoor unit right before defrost. See over here, this is the fresh air intake for the badass HVAC. And so I measure what those are. So this is Lucas Coons here holding the flow hood against here, the flow box. And so we were getting about 70 CFM of fresh air. And this is more than you normally see because this system had a little higher return static pressure than most of the systems that we put in. Speaking of static pressure, it's fun to be able to measure these. So if you use ICP, Carrier, Bryant equipment, or any of the other ICP brands, if you use the top of the line stat, it will tell you static, and it's not dead on, but it's close enough. So here we are. This unit's running at 5th stage, so flat out. There's your EXV, and we are getting 0.28 inches of external static pressure. Now I measured that. So here we are measuring with my Retrotech DM32. So this is a very nice manometer. And if you add these two together, you're at 0.223. So the stat says 0.28, the measured is 0.223, and this is what I have found as well on other projects, that this number is typically a little bit higher than what reality is. But it's within typically 0.05, so close enough. Here is static across the filter, so you can see there's one of my probes before the filter and then the other probe after. 0.09, which is a little more than I would like. Not awful, but a little more than I'd like. And then I turned it down to 2-stage to see what happened to the static. So let's see, where does it show? Indoor airflow is 400 CFM, and we're down to 0.07 static, and that led to about 20 CFM of fresh air coming in. So whenever this fan is running on low, he's at least getting 20 CFM of fresh air, which is very important for a whole bunch of things. We were doing this before it was cool. Then Peter pulled me aside and said, Nate, the vent in my office is really noisy. So this is the duct that goes to his office. And unfortunately, it was the only one that came right off the unit. So the plenum came up and then the duct came right off that. And so he could hear the noise of the air handler. So what I did is pull this chunk out, and I had a piece of flex, and I put a piece of flex in there, and that knocked the noise down. So these are the things that can happen during these projects. This is kind of an interesting thing. This is the annual operating cost for his propane tank, and this is not that far off from reality of what he paid, because he managed to get good numbers. But this is the heat pump water heater that he is installing. So much less expensive. And even if you look at a natural gas tank versus the latest generation of heat pump water heaters, the heat pump water heaters are now cheaper. So this shows a uniform energy factor of 3.55, so that's a 3.55 COP. The latest generation is a 4. So they are quite good. So heat pump water heaters are something to be aware of and to recommend. All right, then we had to do air sealing and insulation. And so I test, and if you do these, you're going to be testing too as you go. So test in was 3,300. Post HVAC, because we pulled a bunch of insulation out and we cut other holes for the ductwork and so forth, we actually made the house worse, which is pretty common. Things usually get worse before they get better. Here's some air sealing done. So these are 10 mat light covers over the recessed lights, which these leak. So I had to bother the foam contractor to go and foam around these. That wasn't this isn't good enough. And then you can see in the outside edges of the house, I showed you a picture outside. These are the top plates over here. So these are ventilation baffles in there, so there's still air flowing in from outside. And then we basically fill this cavity. So you spray down to the ceiling to seal where the top plate is touched by both the drywall on the inside and the sheathing on the outside, and then you spray up. So now there's a lot of R value right at the eave of the house, which is a critical point to have good R value in. This is one of the ducts where it got spray foamed, so we spray foamed them after the fact. And then Jason Julian down in Arkansas is now spraying them before he puts them together. And if ever we do another job like this, that's what's going to happen. That was genius. We were short a man, so I was the one that climbed in the attic and I blew the cellulose, went back to my insulation days. Here's what the ductwork looks like. So here is before that you saw, and after you can see we spray foamed it going all the way up. And so once we did that, we're down to a 2800 blower door, so at least we're beginning to move the house. So we were up to a 4300, doing all that work got us from 43 to 28, and at least we went by where we started. But remember, targets are 22 and 15. So then we needed to do the basement. So here's a basement wall getting foamed, and this one is basically entirely exposed to the outdoors, so important to hit. And then getting into the rim joists up here. Here is Donnie of Affordable Foam spraying a rim joist. So you can barely see it, but he's actually pulling trigger during this picture, and you can see this one is filled. So before, the rim joists looked like this, and they were quite leaky and cold. Here's the system in the basement. Here's the fresh air duct running outside over here. This isn't quite the bad, but it's close. It's at least decent sized, and then it turns to the filter here. And this is a water saver humidifier. This got changed a few months later by Peter, who is an avid DIYer, to the heat pump water heater. He just stole the line that used to go to the air conditioner upstairs because they're both 30 amps. Here is a common leak in basements where a plumbing stack goes up. So this is a square hole with a round thing in the middle of it. So it's kind of funny how that happens, but that's oftentimes a big leak. So we sealed the basement up, and so we started at 4,300. Now we're down to 2,600, but we're not there yet. This is where the bump outs in these houses really matter in a lot of cases. So we dropped everything in the back, and now we can spray foam. So there's two different ways you can do these. You can spray foam them inside and spray this and then the floor here, or you can drop them and you can spray this area here. You have to fill it with something, fiberglass. My favorite use of fiberglass is stuffing a hole before I foam it shut. You spray up and then you spray the floor. So there it is, all opened up. Here it is getting sprayed. And note here the little bit of orange. This is me doing QC. So I don't know for sure if it leaked because I wasn't checking with the blower door. But if it looked like it leaked, I had a little can of foam that I was touching up with. Quality control will make or break these projects. It's really critical. So now we've at least hit that first target. We're down to 2,200. And then we need to do the front unit, and this got mildly complicated because see this bath fan line here turned out to not be connected in there, and it wasn't easy to get to, and we didn't have the product for it. It was the end of the day, so we just packed up and went home. Here it is where it fell off. So this line is supposed to be attached to the bath fan, and it wasn't. So if you've got good contractors, this is Gary Smith of Affordable Foam. He is awesome. He's an engineer by trade, and so he noticed that this was a problem. Also, if you look way down over there, you can see the fiberglass that we stuffed in the hole on the other side of the house. So here's Gary stuffing some fiberglass in that hole so that we can foam against it. After he got the bath fan line fixed up, we're prepping so that we don't spray foam on the side of the house. It won't come off brick. Foam doesn't come off hardly anything. It comes off plastic. That's really about it. And here are the front and the back done. So a good job. You can't tell that this house got touched. We try to make it so it's not obvious. So post bump out, the front bump out, so we were down to 2200, and with everything open up there, there was all kinds of leakage that was happening. So when we sealed that up, we got a huge move. So 2200 to 1640, that's a big move. And then we got into optimization and quality control. So checked how loud the outdoor unit is. These are quite quiet. They're really not obnoxious at all. And so when I had it set up originally, it was set to comfort airflow settings. And there's that 0.27 or 0.28 static. And I changed it to efficiency, and it got loud. But here's an important thing, if you don't understand this, when you get to the edge of what a duct system can handle and you push beyond it, your static pressure goes up really quickly. So if you note here, this is 867 CFM of airflow, and this is 1200. So it's only 38% more airflow, but it's 85% more static pressure. So we go from 0.27 to 0.5. So we're almost doubling. So we hit the wall here. So normally I would leave this on efficiency settings, but it was noisy and it was creating quite a bit of static. So I turned this back to comfort. This is one of the few things that I couldn't hit. This is the front bump out. So there's still some weird thing going on in here that's cold. But we don't have access to it. Here's a before and after. So if you remember the light over the kitchen sink, you can see it here, and it's no longer dark blue. In the bathroom, if you remember, it was cold here, and this is no longer cold. The vents, we didn't change the bath fans, so it's still not great. And then there's a slider that's an issue. But this used to be cold all up here on the top plate of the outside wall, and it's not anymore. By the way, this is a light switch. That's what they look like. This is a big basement window, and it was quite leaky around the trim, so I caulked all that and got a little bit more out of it. So I hunted for everything that I could get at, and I got another 90 points out of it. There was a steak dinner online for this. If I got to 1500, I got a steak dinner. Peter knew that I really pushed for this, and all the other stuff to find, nothing was good to get. There was nothing easy left to hit anymore. And he's like, okay, to heck with it. You get a steak dinner, which one of these days I need to have him make good on, and I'm also going to jump out of an airplane with him. And so then we can look at the feedback loops. One of the things that we love about the Carrier ICP equipment is it's the only one on the market that tracks energy usage on board. So now you can at least put an Emporia view in for $150, an energy monitor, and see what this is. But I love that you can just see this easily. So January and February both used a little under 1,000 kilowatt hours, and he was spending quite a bit of money for propane before. It's $1,100, $1,400 a year, something like that. So these are the two coldest months, and together they're under $300. And these are going to be his highest bills by far for the year, the highest months. This is where feedback loops are super important, and it doesn't have to take a whole lot of time, and you don't have to look at these all the time, but if you look at a few projects, you will learn all kinds of things. So that gives you a good view of going through the process. So he went with a comfort consult and then the comprehensive planning process. So he took the two more advanced options. So that's what we went through, all of that. Comfort consult, CPP, and then you got to see the project actually happen all the way through optimization. This is what the advanced version of the project map looks like. We call this the subway map. So it's very well thought out, and every step has a reason and one specific thing to do, and you don't want to skip steps. If you skip steps, you kill your closing ratio. So an unsold job is wasted time. So the goal of 2.0 is to increase how many jobs you actually sell. And I will link again this video. So this video will roll right into the webinar that I did that was a little more detailed doing this. And you can see Peter, his reaction, what's going on. If you want to see more of these, I did 11 case studies that are really detailed. lots of pictures. They're pretty long, they're 4,000 to 8,000 words. You can see exactly what these look like. So if you are still nervous about this sort of thing, take your fear away with this. But being able to do this, the Energy Smart Home Performance, this is our practice in Cleveland, we developed the process that you just saw me go through by doing these projects. That was the purpose of those projects. And then we figured out how to wrap another process around that for you, the HVAC contractor. And that's it. So hopefully that was both interesting, and it may seem a little scary, but it's not. Again, if you are a service tech, you know way more than what you're going to need to know to do this work. It's not that incredibly hard. We have designed this process so that at least 80% of the work can be done by entry-level talent, because frankly, when you're first learning the building performance side of things, you are entry-level talents. But if you do a few of these, you're going to come up to speed. But again, it is critical to understand that if the HVAC 2.0 process did not have this advanced path, the whole rest of it breaks. Because you need to be able to walk into any house and know with confidence that you can fix it. Like, yeah, you may need some help, but you can fix anything. Like, we've done some pretty crazy stuff. So it's doable. You just have to slow down, have fun, do a little bit of thinking, collaborate a little bit, and you can do it. But also remember, this is going to be maybe 3 out of 100 projects, like if that. So you just need to know that this exists, and when it gets there, you can learn how to do it. So again, I'm Nate Adams, CEO and co-founder of HVAC 2.0. I hope this was interesting. Have a great day. Keep going, and I will see you next time.